Welcome to this explainer, where we're going to calmly, systematically deconstruct what is honestly a massive challenge in artificial intelligence right now, the objective verification problem. We're looking at those highly complex, ambiguous real-world scenarios that you just can't solve with standard software tests or math proofs. You know, there's this idea out there that just throwing more AI agents at a problem will somehow guarantee the truth. But as we'll see, that's not actually the case. Today we're going to uncover exactly why that is and what we actually need to do about it.
Here is our precise roadmap for the explainer today. We'll start with the objective verification problem, move into the agent-team architecture, ask who actually verifies the verifier, look at the danger of recursive drift, and finally unpack the energetic paradigm and structurally controlled intelligence. We've got a lot of fascinating ground to cover, so let's dive right in.
Starting with Section 1, the objective verification problem. Basically, what happens when answers just aren't perfectly objective? Because we have to acknowledge a fundamental reality here. In software, right, we can just run a test to see if the code executes. In math, we use formal proofs. But so many scientific, strategic, or really just messy real-world questions, they cannot be neatly reduced to a simple binary of correct or incorrect. And when a problem doesn't have a perfectly objective answer, verifying it becomes incredibly difficult.
Which brings us to Section 2, the agent-team architecture, or how we go about distributing cognitive work. To address this whole verification challenge, one proposed solution, like the framework from Apodex, is something called an agent team. Now, on the surface, this sounds great. It seems like a highly logical, decentralized, and nicely redundant solution to our problem.
So let's look at how an agent team actually functions in practice. Step 1, a solver agent tackles the problem and proposes a solution. Step 2, a second agent and maybe even several other verification agents independently check the work and try to solve that exact same problem themselves. And then step 3, a global judge agent steps in, compares all of those answers, and decides which one is the most credible. And you can see the appeal, right? It separates context overload. It exposes internal disagreements. And by building in redundancy, it makes it way less likely that one weird accidental mistake is going to dictate the final output. It's obviously better than just asking one single agent to do everything.
But let's move to Section 3. Who verifies the verifier? Because this is where we start seeing the hidden vulnerabilities of AI redundancy. Despite all those clear benefits of distributing the cognitive work, this coordinated system leaves a massive, fundamental vulnerability totally unresolved the second we look closely at that final judging process.
It all comes down to this pivotal question: who actually verifies the verifier? Think about it. Let's say 3 agents produce 3 entirely different answers. That global agent has to step in and make a call on which answer is best. But here's the catch. That global judge is literally just another language model. It most likely shares the exact same training biases, the same blind spots, assumptions, and reasoning weaknesses as the very agents it's supposed to be judging. So sure, adding more agents absolutely increases the number of opinions, but it does not automatically create an independent source of truth.
And that introduces a really fascinating and frankly dangerous concept: correlated failure. Now, redundancy works incredibly well when failures are independent. Think of hardware redundancy. If one physical server fails randomly, another totally independent one can safely take over. But AI agents are not independent physical components. They might literally be copies of the exact same model, using the same tools, searching the same sources, fed by similar prompts. Because of this, you could have 10 different agents confidently reproduce the exact same mistake. They suffer from correlated failure. They converge on an answer just because it sounds linguistically convincing to them, not because it's actually structurally correct in the real world.
So naturally, this leads us directly to something called judge concentration. The agent team system looks decentralized because you have all these different agents participating in the problem-solving process, but the final authority, it's still entirely concentrated in one single judging process. Because of this judge concentration, if that global agent happens to be manipulated, biased, or honestly just poorly calibrated, the entire multi-agent team is going to seamlessly and unanimously approve the wrong conclusion. The core problem was never really about how many agents we deploy. It's about what actually constrains that final judgment process.
Let's transition to Section 4, the danger of recursive drift, which is how errors accumulate over generations. These vulnerabilities we just talked about, correlated failure, and judge concentration, they matter immensely when we apply this architecture to the future of AI. Specifically, when we talk about the process of recursive self-improvement.
This is what we call recursive drift. Imagine an agent team makes a tiny, maybe almost unnoticeable judgment error.
If that unverified, highly subjective judgment becomes the official training data for the very next generation of the AI, that error accumulates. Through recursive drift, an agent team might successfully weed out random, silly mistakes, but it ends up preserving and actually amplifying systematic drift. The terrifying result here is a system that becomes incredibly consistent with itself over time, while simultaneously becoming completely detached from reality. It is honestly one of the most dangerous forms of self-improvement failure.
So, what's the solution? That brings us to Section 5, the energetic paradigm. This is all about prioritizing reality testing over consensus. The answer to recursive drift and correlated failure isn't just blindly adding more AI agents to take a vote on what the truth is. Instead, it requires shifting our entire approach to a totally different architecture, known as the energetic paradigm.
This paradigm completely flips the script on the verification question. An agent team simply asks, hey, which answer appears best, or which one sounds the most intelligent? But the energetic paradigm asks, which answer survives structural constraints and reality? It takes verification away from being just a subjective popularity contest among language models and transforms it into a controlled, rigorous interaction with actual reality.
Instead of asking who sounds the most convincing, this paradigm forces the AI system to answer severe structural questions, like what resources does this proposed solution actually require in the real world? What dependencies have to remain stable for it to even work? What hidden costs are being quietly transferred somewhere else? What contradictions pop up over time? What happens when this proposal hits actual uncertainty or pushback? And crucially, what failure signals would actually force the system to say, okay, we need to revise our conclusion? These are the kinds of hard questions that anchor intelligence to the real world.
And that leads us to the structural constraints themselves. Explicit constraints, preserved evidence, causal consistency, resource and cost limits, contradiction detection, and observable feedback. Now, under the energetic paradigm, those specialized agents we talked about earlier, they are still incredibly useful. You can have one generating hypotheses, another digging for evidence, another flagging hidden costs, and another challenging base assumptions. But, and this is a massive but, none of them possess the unlimited authority to just declare an answer correct. Their outputs mean absolutely nothing unless they survive these rigid structural constraints.
Moving into our final section now, Section 6, Structurally Controlled Intelligence. This is the true breakthrough in verification and really the core of what we're talking about today. An agent team can absolutely distribute cognitive work and reduce context pressure for sure, but it doesn't fundamentally solve the verification problem.
The real breakthrough here is identifying exactly why an answer remains valid, what invalidates it, and knowing precisely when the system must stop, revise, or entirely reverse course. The true leap forward in AI isn't going to happen just because a system can rapidly spit out dozens of slightly different answers. True verification demands an architecture where disagreement, real-world consequences, hard evidence, and course correction remain structurally active throughout the entire process, not just a system optimized to generate a high volume of opinions.
I want to leave you with this defining quote straight from the source material. That is the difference between coordinated intelligence and structurally controlled intelligence. As this explainer has shown, we really have to look past the shiny illusion of decentralized agents. So I'll leave you with this final, provocative thought to chew on. As we keep pushing the boundaries of recursive self-improvement in AI, are we merely building systems that coordinate their opinions just to sound perfectly convincing to themselves? Or are we going to demand systems that are rigorously controlled by the unyielding limits of reality? Thank you so much for joining me for this explainer, and definitely keep asking those hard questions.